look at, the next topic is going to be section 3, adding and subtracting fractions. Now, there's one word or two words that haven't been mentioned. There's one topic that hasn't been mentioned in any of the fractions that I've done so far. It has to do with adding and subtracting of fractions. What's the deal? What do you have to have before you can add or subtract two fractions? You have a calculator, right? Yeah. You have to have a common denominator. But if you have a calculator, that will take the place of a common denominator. Did you know that? Did you know how to do this with, let's use a calculator to do a problem like 1/2 plus 1/5. Does everybody know how to do that? With the calculator? All right, you got an A to the B over C button on your calculator? All right, take your calculator and go 1 divided by 2. 1 divided by, no, wait. No, it's 1, I beg your pardon, let's start over. 1, and then do the A to the B over C button. Do a 1, and then do A to the B over C button, and then 2. Okay? And then do plus, then take 1, and then give it A to the B over C button, A to the B over C button, and then 5. Okay? And you see what the calculator is doing is taking 1 over 2, and it's expressing it as a fraction. And then you're going to tell it to add to this 1/5, and then equals. And what does the calculator give you? 7/10. Isn't that neat? Do you know what the calculator did? The calculator found a common denominator and did all this work for you. Let's see what the calculator had to do. You said the calculator gave you an answer of 7/10. Now it didn't write it 7/10, did it? What did it write? 7, and then this 10. Does it do something like that? 7, and then some little hickey, well, I don't know what that's called, 10. 7 something 10. Okay, and that means 7/10. Now, what the calculator actually did, if you did this without a calculator, you can't add halves and fifths, can you? Because they're not like. So what we have to do is convert both fractions over to a common denominator. What's the common denominator going to be between 2 and 5? You probably know that instinctively, don't you? 10. In other words, what we'll have to do is change this to tenths. This will be tenths, and then this will be tenths. And then if we're adding tenths plus tenths, then you can do it, right? So what would you have to do to change 1/2 to tenths? You'll have to multiply this denominator by something. You see, in order to make this into tenths, you have to ask yourself, what's missing in this denominator? If you've got a 2 and you need a 10, what's missing? And I didn't hear anybody say 8, did you? Right? Nobody said 8, because we're talking about factors. What would you have to multiply this 2 by in order to get 10? The answer is 5. Now, if you're multiplying the denominator by 5 in order to get 10, don't just multiply the denominator by 5. What else must you do? You must multiply the numerator also by 5. In other words, you multiply the numerator and denominator by what's missing. And if you forget to multiply the numerator by it, it's all over. You blew it away. So what about the second denominator? What factor is missing? 2. So that would be times 2. And that would give you what? 5/10 plus 2/10. And now you've got a common denominator. Just add them together. What would you have? 7/10. Now I did this with a ridiculously simple question like this. This is a simple arithmetic question, and I took all this time hopefully to make you stop and think about what we're doing when we add fractions. When you add or subtract fractions, I have it outlined in a little handout that I gave you. This little handout says there are 3 steps for adding and subtracting fractions. Okay? And the first step is you must find the common denominator, and then secondly you must add or subtract the numerators. And then the third thing is to try to reduce the fraction. That's sort of a guideline that I've given you. And there are some sub-steps under that. By the way, if you're watching this on a videotape, just give my office a call, and I'll send you out a copy of that little one-page handout. Or maybe they're available in the Learning Center, I'm not sure. Oh, by the way, this is a Hunt Club production. Just thought I'd mention that. Got to plug the Hunt Club operation here. This is coming to you live by video from the Hunt Club. Except nobody's watching it live except these folks that are here. Okay, let's get on with this. The first thing you have to do to add or subtract fractions is find the common denominator. So let's take some problems on page 267. I just want to get a feel for what a common denominator would be if it has algebra expressions in it. Number 10, the problem says 4 divided by 5y and 3 divided by 4y squared. Now, what would be the common denominator? What number is there that both of these denominators will divide evenly into? 20. And you've got y squared. Now, the deal on powers is if you ever have variables to different powers, take the highest power of any denominator, and that'll do it. So the LCD here would be 20 what? Y squared. 20y squared. Okay? Number 12. Number 12, the problem says 5 divided by 2x and 7 divided by 2 plus x. Now in this case, you've got 2 for a factor, you've got x for a factor, and you have 2 plus x as a factor. Do you see this 2 plus x is a quantity, and it's a separate factor from the 2 and from the x. So what would I have to have for the LCD?
2x.
2 and x, and times the 2 plus x, right? So you have to have all of those factors because this 2 and the x and the 2 plus x each represent separate factors. So you'll have to have all of those in the common denominator. Number 14. Number 14, the problem says 1 divided by 2x minus 1 and x divided by 2x plus 1. So, now, can you see that 2x minus 1 is a distinct factor? And the 2x plus 1 is a distinct factor, right? So the LCD will have to have both of those factors, and that would be 2x minus 1 times 2x plus 1, right? It has to have both of those factors. All right? Any question on that? Okay. Number 16. I'm just going to run down the line of all of these even problems in finding the common denominator. 2 divided by 3a plus 9. And the second fraction is 5 divided by 5a minus 15. Okay? Now notice the numerators are kind of irrelevant in this whole exercise. We're just trying to find the common denominator for these. Now, what we have to do to find the common denominator, we have to look to see what factors are present in each denominator, right? The key word there was factor. So we need to factor this denominator, don't we? How would you factor that denominator? 3 times an a plus 3, right? Can you factor this denominator? Did I copy that right? I did, didn't I? What's the factor here? 5 times a minus 3. Now, can you see that you have all separate factors? You've got a factor of 3. You've got a factor of a plus 3, you've got a factor of 5, and a factor of a minus 3, so what is the LCD? It's got to have all those factors, which would be, now take them in any order you want. Let's take the smallest ones first, like what, the 3 times 5? 3 times, you go ahead and multiply it out, call it 15, because that's convenient to multiply it out. 15, what? A plus 3, a minus 3, right? So you have to have all of those because they're all separate, distinct factors. Any question on that? Let me change the problem. Change that problem now. All right? I'm going to change this to a plus. It's no longer number 16. I have changed the problem, and I've made this a plus. All right? Now, let's change the answer. What would the answer be? This is going to be a plus 3. Now, what would you have to have in your common denominator? The LCD now for my new problem is what? 15. And what about the a plus 3?
Square it.
Do I have to have it squared? Now, if it's the first power here and the first power there, you don't need both of them, do you? You only need one factor of a plus 3. You see? One factor of a plus 3 will take care of both of them. So the common denominator is not a plus 3. Well, a common denominator would be a plus 3 squared. But the least common denominator only has a plus 3. Right? There's no need to have a plus 3 squared in your common denominator. Okay? You only take the highest power of any given factor. All right? Any question on that? Okay? Be sure to stop me if you have a question. Don't be intimidated by that camera. Okay. All right, now one more in that list. The most important one of all, number 18. And the problem says 2a divided by a squared plus 8a plus 16. And the second fraction is 7a divided by a squared plus a minus 12. And remember, we're trying to find the least common denominator. How do we find the common denominator? You have to factor the denominators so you can see what factors we're going to build with. Okay? So let's factor that denominator. What would that be?
A plus 4
A plus 4,
twice.
the quantity squared, right? Now, if you put a plus 4 times a plus 4, you're right, but you won't get the common denominator. It's likely you'll miss the concept of the common denominator. So be sure to put, if you start off with a plus 4, be sure you put a plus 4 squared. Be sure to write it that way. And now what about this one? A plus 4, a minus 3. Okay? Now, what is the LCD? Remember now, the LCD is going to have all the factors of every denominator. And if there's an a plus 4 in more than one denominator, what power do we use? The highest power, right? The highest power. So what's the a? We're going to have in our common denominator, yes, we're going to have an a plus 4 raised to the first, the second, or the third power?
Second.
The second power, because all we take is the highest power of any given factor. So you don't need all of them, you only need the factor to the highest power of any given denominator. Is that clear? And then what else do we need in this common denominator? You also need a minus 3, right? You also need an a minus 3. Any questions on that? Okay, good. All right, now, having done that, then we'll take a look at some problems where you actually have to add or subtract fractions. Okay. Still on page 267, we're doing number 20 for the first problem. Number 20, the problem says 10 divided by 7x minus 5 divided by 2x. All right? Now, my feeling is the first step should be to find the common denominator. If you can just fake it, do it in your head, that's fine. If you have to do some factoring, if you have to break the numbers down to see what factors are there, do whatever you have to do. In this case, between 2 and 7, you probably can come up with the LCD, can't you? What would it be? 14? And do you have to have an x? Yes, you have to have an x. So you have to have a factor of 14 and an x. 14x is the common denominator. Now, the way I've been having students do that, let me repeat the problem. 10 over 7x minus 5 over 2x. I just want to repeat the problem so I can work on it. And then, what I've been having you do is make one long fraction line with the common denominator underneath. The denominator of your answer is going to be 14x. So I draw one fraction line and I put the common denominator in the middle underneath the fraction line. So that's going to be the denominator. In other words, the denominator is all fixed. Right? And that does step 1 of my 3 or 4, what have I got? 3 steps in my handout? I lost my handout. There are three steps, right? Okay. Part 1 of my handout is to find the LCD and put it down. Now we go to part 2. Part 2 is what I call playing the what's missing game. Now, when you compare this denominator right here, this denominator, to the common denominator, look at this and then look at this, compare them back and forth. Is there something missing here? What's missing? 2. So whatever's missing, we're going to multiply by what's missing. So we're going to go times 2. Now, you don't just go times 2, do you? What's the most important thing you've got to remember here? Numerator and denominator both by 2. Don't just multiply denominator by what's missing. Multiply the numerator and denominator both by the same number. That way you don't change the fraction. You see, you multiply by 2 over 2, which is 1. The mathematicians want to emphasize that this is 1 that we're multiplying by, and therefore we don't change the value of the fraction. But I just wanted to have you remember, multiply numerator and denominator both by what's missing. Now what's missing in the second denominator? 7. So what we'll have to do is do the second fraction, numerator and denominator, both by 7. Now that concludes step 2, which is play what's missing. Now step 3 is to just go ahead and jump in and do what it says to do for the new. Now we already got the denominator, right? This is this, and this is this, and this is that. So the denominator is all taken care of. What's the one thing left to do in this problem? The numerator. And the numerator, we just read from left to right. Just read it like it reads there. What's that say? 20. Okay, that would be 20. And then what does it say? Minus. Okay, minus. And then what does it say? 35. And what would that give you when you simplify the numerator? And then try to reduce the fraction if you can. What do you get? Negative 15 divided by 14x, right? That's it. Any question on that? Okay? So all this thing about fractions being so hard, if you really understood the idea of common denominators and playing this game of what's missing and get some practice at this stuff, it's not going to be as hard as you think it is.
Can you do this on a calculator?
Can I do that on a calculator? I don't think you can do the algebra on a calculator unless you have a graphics calculator. Now, if you have a graphics calculator, then you can, you might be able to do it. I'm not sure. I got to look into that. Next term is when I'm going to really get into calculators. So ask me next term. I hate hard questions like that. But I do know that there are computer systems like Derive and Maple. There's a couple of other computer systems where you can input algebraic expressions and the computer will you just tell it what to do. You tell it to simplify and it simplifies. You tell it to factor and it factors. And it'll do that for algebraic expressions exactly as you give them to them. So I know we got the equipment. I'm just not sure if it's in the calculator right now. Okay? Now, as another example, look at number 26. Number 26, the first fraction says x plus 1 divided by x squared minus x minus 20. And then it says minus, and the second fraction is 2 divided by x plus 4. Okay? Now, what should we do first? Find the common denominator, and in order to do that, your first step is to factor those denominators. Right. Now, what if you had a numerator up there? Would you be worried about factoring numerators in an addition-subtraction problem? No. You don't usually need to worry about factoring a numerator unless factoring the numerator reduces the fraction and makes the common denominator simple. Other than that, don't worry about factoring numerators. Make your priority factoring the denominators. That would be what? X plus 1 divided by what? X minus 5, X plus 4. Okay? And then we got this minus sign, and then we've got the second fraction is 2 divided by X plus 4. Okay? Now, my next step is to find the LCD. Can you do that? The LCD is going to have in it an x minus 5 times and x plus 4, right? It has to have both of those factors. It doesn't need an extra x plus 4. You only need one x plus 4, right? So the common denominator is going to be x minus 5, x plus 4. Now, the next thing I'm going to do is write down one fraction line and put the common denominator in place. X minus 5, x plus 4. Okay? Right? Now, after you put the common denominator in place, then I need to go back and, by the way, that finishes step 1. Step 1, find the common denominator and put that thing down, and that's it for once and for all. One fraction with one common denominator. Okay? Now I've got to go back and do step 2. Do you remember what step 2 was? Play what's missing. Okay? So if you want to play what's missing, I have to compare this denominator to this denominator. Do you see anything missing? There's nothing missing. So if there's nothing missing, what do? Don't do anything. Go on to the next part. You see something missing down here. X minus 5 is missing, right? So what are we going to do here? Multiply by x minus 5 and the numerator also by x minus 5. So we're going to multiply by x minus 5 over x minus 5. Now that concludes part 2 of the problem, which is playing what's missing. And now we go into the third phase of the problem. The third phase of the problem, we've already got the denominator in place. What do we need to do? We need a numerator. What's the numerator going to be? Let's start with the x plus 1, okay, x plus 1. And now, what about that minus sign? I want you to know that minus sign is going to affect everything that follows in the fraction. And in other words, it might be a good idea to slow down. I give you a little caution sign there to warn you to slow down. You're about to go around a curve in your mathmobile, right? And that means slow down. Negative what? Negative 2x would be what? Negative 2x. And then what? Negative 2 times a negative 5. Negative 2 times a negative 5 would be a positive 10. Is that right? Positive 10. Okay? And now the next thing is, can you simplify that? Well, you can simplify it, can't you? 1x minus 2x would be negative x. You simplify it by combining like terms. That's all. Just combine like terms. Negative 2x plus 11, right? Negative 2x plus 11. And the denominator would be x minus 5 times x plus 4. And that's it. End of story. Can't simplify it, can you? By the way, a lot of people are going to forget this negative times the negative and end up with a negative right there, and they'll have a wrong answer. That's a very common mistake. Watch out for those, especially on the final exam. On the final exam, which is multiple choice, can you see what a mathematician is going to do to you on that? They're going to expect you to make that error, and when they give the wrong answers, that will be one of the choices. I can guarantee it. Okay? So don't make those predictable errors. All right, any question on that? Okay, let's go on down to number 52. Number 52. Number 52, it says x divided by 25 minus x squared. And then it says plus, and then the second fraction says 2 divided by 3x minus 15. First of all, if you factor the 3 out of this, do you see what we're going to get? 3 times what? X minus 5. Do you see that this is not exactly what I'd like it to be? This is 25 minus x squared. What would you rather have than 25 minus x squared?
X squared.
X squared minus 25. Can you think of anything we can do that would generate such a thing? Multiply the numerator and denominator both by negative 1. Let's multiply the numerator and denominator both by negative 1. And then you'll have a numerator of negative x. Let me get the right color. Negative x. And the denominator would be 25 minus x squared, right? 25 minus x squared, which would, x squared minus 25, which would be x minus 5 times x plus 5. You see what I did? By multiplying the numerator and denominator by -1, I get negative x divided by 5 minus x5 plus x. And then I've got this plus the second fraction, which is 2 divided by 3 times x minus 5. What would be the common denominator now? The common denominator now, what do you have to have in the LCD? LCD is going to have a 3 and an x minus 5 times x plus 5, right? Okay, so let's go ahead and put down the common denominator. Put down the common denominator, one fraction line with the denominator, which would be 3 times x minus 5, x plus 5. Okay? So that completes step 1. Find the common denominator and put down the common denominator. And you're all set. Except for step 2, which is to play that what's missing game. So compare this denominator to the common denominator. Can you see something's missing there? What is it that's missing? The 3. So what I'm going to have to do is multiply times 3 over 3. Okay? What about the second one? Is something missing in the second fraction? What would it be? We got the 3, we got the x minus 5. What's missing is the x plus 5. So I'm going to do numerator and denominator both by x plus 5. Now what? Now you finish step 2, which is play what's missing. Now we're ready for step 3, which is to say, let's take this and put down we got the denominator, we need a numerator. So where am I going to get a numerator? First place is right here. What's it going to be? Negative 3x, okay? And then I got this plus sign in the middle, right? Because it says plus, so I'm going to put plus. If it's minus, I'm going to put minus. And then what am I going to have? 2, multiply this out, right? That would be 2x, and then what? Plus 10. Multiply it out. And then ask yourself, can you simplify it? Can you simplify it? X, and then what? Plus 10? Negative x plus 10, and the denominator is going to be just what it is there. 3 times x minus 5 times x plus 5. And it doesn't reduce, doesn't simplify. That's all you can do for it. Okay, any questions on that? Okay, skip on down to number 66. Now I'm going to have to give myself a little more room on this. Number 66. And then I want to do one more problem on this section to lead into the next section. I'm taking a lot of time with this because we don't teach common denominators in basic algebra. Shame on us. You should have been taught. I really believe that our department made an error when we said we won't teach common denominators in basic algebra. And I'm going to risk saying that on camera, but I think it's an important thing that you need to have. And I'm taking a little extra time on this section because I realize you have not had common denominators before. So I have to make up for all that right now in intermediate algebra and still save some time to do complex fractions next. So here we go with number 66. 3 divided by x squared minus 9 is the first fraction. And then it says minus the second fraction. The second fraction is x divided by x squared minus 6x plus 9. And then the third fraction, it says plus, and the third fraction is 1 divided by x plus 3. Now, the first step is going to be to find the common denominator. We do that by factoring each denominator. Okay, can you factor each denominator? X minus 3, x plus 3. What about this one?
X
Minus 3, x minus 3. If you're thinking to do this as x minus 3, x minus 3, that's okay, but how do you have to write it to get the next concept? You have to write it x minus 3, the quantity squared. And then this one, x plus 3, that's okay like it is. Now, Drum roll time. What is the LCD? We have to have in our common denominator, we got to have x minus 3, don't we? Do we have to have x minus 3 or do we have to have x minus 3 squared? Squared. Remember, we take the highest power of any x minus 3 factors. Take the highest power. And what else is there in this problem?
X plus 3.
X plus 3. Do we need an x plus 3 squared?
No.
We got 2 of them. We got one here. We got one there. We don't need 2 of them because we only have one in each place. So we need the highest power of any given factor. So that's the common denominator. So let me come down here a ways and I'll tell you what, that's kind of nasty. Let me rewrite this whole thing. 3 divided in a factored form. 3 divided by x minus 3, x plus 3. And then I got plus, a minus. I've got an x divided by x minus 3 squared. And then I got a plus, and I've got a 1 divided by x plus 3. Whatever you do in the homework, when you start writing these things down, be sure to leave space. Paper is cheap, isn't it? Leave space for you to put stuff in the middle. You know, don't jam yourself up. Spread the work out so it'll look nice when you finish. And now I need to put down the common denominator, one fraction line for the whole problem with one denominator underneath, and that's going to be the common denominator of x minus 3 squared times x plus 3. Is that right? Now, compare the first denominator to the common denominator. Do you see something missing?
X minus 3.
We need an extra x minus 3, don't we? See, we've only got one x minus 3. We need another one. So we'll have to multiply this one by x minus 3 over x minus 3. What about the second one? Is anything missing down here? X plus 3. So we'll have to do this one by x plus 3 over x plus 3. And what about the third one?
X minus.
Well, we got 2 factors missing there, don't we? We've got an x plus 3. We're going to be missing the x minus 3 squared. So we'll multiply it by x minus 3 squared. Okay? Now, that's finishing up the game of what's missing. And we're ready for step 3 in the problem. Step 3 in the problem is we've already got the denominator, we need numerator, right? So what's the numerator? Give me the first part of the numerator. What would that be? 3x. Okay, and then what? Minus 9. Now do the second part, which would be being careful of that negative. You've been warned. Negative x squared, and then what? Minus 3x. Okay, minus 3x. Good. And then we've got this plus, and now we have to do this part. And you might as well just go ahead and multiply it out. Just go ahead and multiply it out and see what you get. X squared, okay, x squared, this part down here, x squared minus 6x plus 9, right? When you square out x minus 3 squared, it's going to be x squared minus 6x plus 9. Any question on that? Now, did you wonder why am I multiplying this out? I'm multiplying it out because I'm going to be combining the numerators together. But I didn't multiply out denominator, did I? Does that seem unfair? Double standard? You're treating the numerators one way, denominators another way? Right. That's right, we are. Because there's a different thing we're doing with the denominator. The denominator is the denominator. And if you want to multiply that out, have at it. It's going to be about that long. It's going to be ugly. And it won't tell you anything. Why would you want to multiply out the denominator? Because that's it. There's no advantage in multiplying out the denominator. Then why am I multiplying out all these numerators? Why am I multiplying those all out? So I can add them together. You see, I'm combining the numerators together. And that's what I have to do. Now, do you see what happens in that numerator? In the numerator, how about x squared minus x squared? That subtracts out, doesn't it? Now what?
3x.
3x minus 3x, that subtracts out.
Negative 9 positive 9.
Negative 9, positive 9, that subtracts out. Isn't that nice? Okay, now what's left?
Negative 6x.
Negative 6x. That's all you've got left, negative 6x. And the denominator is the common denominator, which would be x minus 3 squared times x plus 3. Okay? And that's it. That's how we do the common denominator. Okay? Now I got one more problem I'd like to do from this section that leads us into complex fractions, and that is number 58. Number 58. All right, on page, same page, 268, number 58, it says parenthesis 2 divided by 3 minus 1 divided by x, and then it says divided by, and it says 3 divided by x plus 1 divided by 2. Okay? There's the problem. Now in this case we've got parentheses, divided by, and parentheses. What's the order of operations say you have to do first?
Solve each parentheses.
Right. Order of operations, if there are parentheses, says you have to do what's in the parentheses first, right? So let's take that as a clue as to what we should do, and that is to just put down the common denominator in here. Let's do just the pink part, ignore the blue part, get the common denominator right in here, which would be 3x, right? Now when you get the common denominator of 3x, you can play what's missing if you'd like, which would be what? What's missing in the first one? X over x. What's missing in the second one? 3. 3 over 3. So what is the numerator of this answer? 2x minus 3. 2x minus 3, right? Now let me show you a shortcut. Let's not play what's missing. Take that away. I want to show you a shortcut, and that is anytime the product of the denominators is the common denominator, 3x is the common denominator, the product of these is the common denominator, you can just take 2 times x is 2x minus 3 times 1 is 3. 2x minus 3. Okay? And that's a little bit of a shortcut that applies anytime the common denominator is the product of the two denominators. Now the reason I wanted to show you that is because it's useful in the next one. You see in the blue fraction over here, let's do the same thing. What would be the common denominator? 2x. And then what's the shortcut for getting the numerator if the product of these two is the common denominator? 6. Okay, 6. And then what? Plus x over 2x. Okay? Any question on that? Now you can continue to play what's missing. You can use the shortcut. You can do it whichever way you want. And then in the middle is this division sign. Now you've changed it into a regular division problem, just like what we did in section 2, 6.2. Now what would you do with this? Invert multiply. So this would be 2x minus 3 divided by 3x times, we'll invert this, and what would it be? 2x divided by 6 plus x. And now can you see anything that divides out? Not a whole lot. Now this, remember, this is 2 times x, this is 3 times x. The x is a factor, isn't it, out there? And this x is a factor. So the x divides out. That's all you can do. So the answer would be, the final answer, we've got a 2 times the quantity of 2x minus 3, and we've got a denominator of 3 times the quantity of 6 plus x, or x plus 6. Okay? Any question on that? All right. Now that finishes up the hardcover book, and now I want to go to the one-step book and take a look at something called complex fractions. All right. Any questions on this? Okay. Oh, okay. Good question. The question was, can you multiply this out? You can, and if you did, you'd get this. You'd get 4x minus 6 divided by 18 plus 3x. And that would also be an acceptable answer. But the question is, which is preferred? Can you look at that and see that it does not reduce? You can't, can you? You can't see that you see, if you write it in the factored form, you can see that it doesn't reduce. So I prefer the factored form. Most of the times the book will have the factored form in the answer book. Okay? All right, now, I want to look at something called complex fractions. As if fractions isn't bad enough, we have complex fractions. You know what a complex fraction is? Complex fraction is a fraction that contains fractions within the fraction. For example,